Alright guys, so this is episode 3 in my series on making a 2D game in Android Studio, and in this episode we're going to be creating a manager for actually moving the obstacles that the player has to avoid down the screen. And before we get into that, we're actually going to add one thing into our main activity class, and that will be for us to get our screen dimensions, so like the width and height of the screen pixels. And we actually need a place to store it. So I'm going to come over here, and of course we could store it in the main activity class, but I'm going to choose to make a constants class just in case we want to add other stuff later. So we're going to make a public static int, and it's going to be screen width, and we're going to do the same thing for screen height. Alright. Now I'll just close that out. That's done. And over here, what we're going to do is we're going to actually assign those a value. So we're going to do display metrics, and we're going to make a new display metrics, and then we're going to say get window manager dot get default display dot get metrics, and then we need a metrics for it to output to, and that's going to be dm right over here. And now we want to do constants dot screen width, and that's going to be equal to dm.width pixels. And similarly for height, we're going to do screen height, and that's going to be equal to dm.height pixels. Go ahead and save that. And now we have our screen dimensions being stored in our constants class, and that's all good. So we're going to want to come over here and create a new class, and we're going to call it obstacle manager. Create it. We're not going to actually have this extend game object, even though we're going to have all the methods that game object requires, but I'm just not going to do that. But anyways, before we start making this, we're going to want to go into our obstacle class, and we're going to add, I've already added it because I was going over what I was going to do earlier. And all you need to do is add a getter for this rectangle, so just public rect get rectangle equal, and then have it return our rectangle. And that's all you need to do in there. And go ahead and close that out, or leave it there, but go back on to obstacle manager. Now I'm going to give a brief overview of what this is going to do. So what we're going to do is we're going to have them moving down the screen, and of course we never want a spot where like a blank empty spot. We always want there to be obstacles. And so because of that, we want to keep instantiating obstacles as they go off screen, and we want to have a little bit of buffer room. So we want there to be obstacles with negative y values that are going to come onto the screen, but they're always the region that we fill with obstacles is going to go off the screen, so we never have to worry about there being like a gap. Okay, so while our obstacles, we're going to store them as an array list. And it's going to store type obstacles, obviously. And it's going to be obstacles and leave it at that. Now we're going to make our constructor. And this is going to take in, I believe, just one argument. And that's going to be the width of the gap that for the player to fit through. And so that's just going to be int player gap. And so actually come up here, create another instance variable for player gap, and then whoops, I didn't define the type. Okay, and then just assign player gap to our argument, and then we're gonna instantiate obstacles. It's just gonna be a new array list, and now we're gonna create a method that's called populate obstacles, and that's going to populate our first thing of obstacles. So we're going to create a private void populate obstacles, and what it's basically going to do is, like I said, we need some extra room on the screen. The region we fill has to be larger than our screen height. So I'm going to choose to make it 4/3 our screen height, which for me that feels like a comfortable like overflow. We've got a third of the screen height and overflow, and so that seems like a reasonable thing. So anyways, I'm going to do current x, and we're going to start at negative, and it's going to be 5 times, and then we're going to do constants dot screen height, and then we're going to divide that by 4. So 5/4 screen height. And just so you know, we're doing integer division right over here. And because of that, you have to do it in this order. 5 times it divided by 4. You can't just do like times 5/4 over here. That won't work. And anyways, so once you've done that, we're going to say while, and I'm going to add a comment up here. I'm going to choose to have higher index equals lower on screen equals higher y value. So basically, the larger the index, the further down on the screen that obstacle is. So I'm going to say while obstacles dot get, and then it's going to be obstacles dot size -1. So we're going to get the last index, and we're going to say dot get rectangle dot, and we're going to say bottom is less than 0. So this is the y value of the bottom of the rectangle, and we're going to say while it's less than 0, while it's hasn't gone onto the screen yet, then we're going to keep generating rectangles or obstacles. So what we're going to do is now we need to create a random gap, so to speak. And I actually want to add one more thing here. Sorry, before I get into that, I'm going to say int obstacle gap. So this is the gap between obstacles, because you want to give the player some room to move around. So we're going to need to get that, and we'll just say this dot obstacle gap equals obstacle gap. Alright, that's good. So now, while we're generating these rectangles, like I was saying, we're going to need to generate a gap for the player to go through. Now, we don't want that to be in the same spot every time, so we want to generate a random x value for that to start. And the way we're going to do that is the following. So, here's what we're going to do. We're going to say int x start, and it's going to be equal to math.random, and this will generate a random number between random double in between 0 and 1, and 0's inclusive, 1's exclusive. And we're going to multiply this by the following. So it's essentially just going to scale it. We're going to do constants dot screen width minus our player gap. The reason why we have to subtract this player gap, and let me do something. I gotta typecast this to an integer. Make sure you can close the whole thing in brackets, so you're typecasting the whole thing. Otherwise, you'd be just typecasting this random number, and that would always just scale it down to 0, which we do not want. Okay, but the reason I subtract player gap right here is because if we just did the whole screen width, it could generate an x. Say here's the edge of the screen, right where my cursor is. It could generate an x that's right here, and then we'd make the gap go out to here, but that'd be off screen, so the player would have no way of getting through it. So that's why we have to make sure there's always room for this player gap. Alright. And we're going to modify our obstacle thing right here, okay? Because we don't want it to just be a plain rectangle, we want it to essentially be 2 rectangles with a gap in between it. So what we're going to do is say, we're going to pass in an int, and it's going to be start x, and an int that's going to be player gap. And we're going to store these. And we're going to assign them. Save that, and now we're gonna do I'm actually gonna make a few changes to this. So in the draw, we have to obviously make some changes, and that's gonna be the following. So we're gonna get rid of this rectangle, I know, but that's just the way we gotta do it. And we're gonna actually instead replace it with a int rect height. And my apologies, guys. We're actually going to change a few things. So we're going to say private rect, and this is going to be rectangle 2. And I'm just going to choose to move it because we're going to generate 2 rectangles using these arguments. That's going to be just 2 rectangles aligned with a gap in between them. Okay. So delete that, and we obviously have to delete this because we don't have a rectangle argument. And now what we're going to say is we're going to say rectangle equals a new rectangle, or a new rect. And okay, I gotta remember these arguments real quick. My bad, guys. Okay, so left top, right bottom. Okay, so our left is of course going to start out as 0, and our top is going to be, and again, we need to pass in another argument. I'll do int start y. And this is just going to be, our top is going to be start y. Our right is going to be, it's going to be start x, and our bottom is going to be start y plus rect height. Perfect. Now we're going to make rectangle 2, which is going to be the rectangle on the right. This is going to be, again, a new rect, and this is going to not start at 0. The left is going to be at start x plus our player gap. And then we're going to do our top, which is just going to be start y. And our right is going to be constants.screen width. And this bottom is going to be start y plus rect height. Perfect. And so now we're just going to add another line in this draw. We're going to draw rectangle 2, and pass in the paint. That is good. Alright. Now we want to come back into our obstacle manager, and now when we're generating these, we're going to do the following. So we've generated our start x, and our start y is just going to be current y, and our obstacle height we'll actually add as another argument here. You could of course make it constant, but I want us to be able to choose. Okay, store that. Okay, finally, we can come back here. So we've generated our random start x. So then we're going to just say obstacles dot add, and then we're going to say new obstacle. And what's its argument? So it's going to be rect height. So obstacle height, comma, color, which is going to be, oh my god, every time. So we have to do another thing, int color. We got to store that. Sorry guys, but we'd be typing this all anyway. So anyway, so we're gonna pass in color, and let's check the arguments. So it's color, then we gotta do start x, start y, and player gap. So start x is x start, and then we need start y, which is current y, and lastly we need our player gap, which is already stored. So that's good. We added a new rectangle. Now we got to add to current y, and by that we will, and to do that we will just say plus equal, and then we'll do let's see, we'll do obstacle height plus obstacle gap. So that, so we kind of skip the whole, we add to the current y the obstacle height, the obstacle we just created, as well as the gap we want to leave in between them. So that's good, and that should populate everything. So now we want to create a public void update, and we want to do public void draw. It's going to take in a canvas, and for this we want to just say for, and then we'll do obstacle ob in obstacles for each. So for each obstacle we're just going to call ob, and then we're drawing the obstacle on the screen. Now the update is going to be a little different. We're actually going to need to store another variable, and that's going to be private long, and it's going to be start time, and I'll explain this in a sec. Over here we're just going to say start time equals system dot current time millis. Alright, so we don't, this update frame, we don't want to add to all the obstacles x values. We don't want to, y values, we don't want to add to them each frame. We want to do it based on time, and that's so that we have this frame rate independence is what it's called. And so here is what we are going to do. We're going to go ahead and see how much time has passed since the last frame. So we're going to say elapsed time, and that's just going to equal system dot current time millis minus start time, and then we're going to set start time equals system. We'll actually save that. No, start time, we'll set it right now. We'll say current time millis, and this we're going to have to typecast it to an integer. Alright. So we're going to want a scaling speed. So basically, let's say we're going to want a speed. Like, how far is it going to want to move per second? And we'll define that right now, and we'll do it as, like, just right over here. We'll say, let's do float speed, and it's going to be equal to, and we're going to say constants dot screen height, and we're going to define how many seconds we want it to take to move down the whole screen. Later we'll make this change over time so it can get harder, but let's say we want it to take 10 seconds to move down the whole screen, and this is obviously in milliseconds, that's why I did 10,000, and add a 0.0 f. Okay, that's our speed. Now what we want to do is just say, we're going to say for each obstacle ob in obstacles, we're going to want to add to its y value. And so we're going to need to make a method over here which will allow us to increment the y value. So we're going to say public void increment y. And then we'll take in a float y, and then we'll say rectangle dot, and then we'll say, we'll set the top plus equals y, and we'll say the bottom plus equals y. And similarly for rectangle 2, we'll move it down a bit. Alright, so coming back into here, we're just going to say ob.increment y, and then we're going to say speed times, and then we're going to do elapsed time. And that should be good. We're going to shift it all, and then we're going to add a quick check. We're going to say if. Then what we're going to do is we're going to say if obstacle dot get obstacles dot size -1 if the last obstacle, and we're going to get the get rectangle dot top is greater than or equal to our screen height, so it's off the screen. Then we're going to want to generate a new rectangle, and we're going to do that the following. We're going to say obstacles dot add, and then we can define an index. We want to add it at index 0, and we're going to say a new obstacle. And so we need its rect height, which is just going to be obstacle height. We need its color, which is going to be color start X. We're going to have to generate a start X. So let me do that right here. Copy this. So we're going to do X start. Let me check here what else we need. We need a start Y. Okay, this is where we're going to do the following. Our start Y, we'll do that in a sec, but let's pass in the player gap. So our start Y is going to be the following. It's going to be obstacles dot get 0, so we're going to get the highest up one dot get rectangle dot top plus obstacle height plus obstacle gap. And that will basically leave the gap between the obstacles that we want when we generate a new one, and we're adding it to the top because we want the lowest index to be the higher up on screen. So that's good, and I'll keep generating them as they go off screen. Now I believe we can almost test. We want to now just go over here into our game panel, and we're going to want to add in a private obstacle manager. And of course on create we're going to want to instantiate it, so we're going to say obstacle manager is a new obstacle manager. Now let's see what we want to put in here. So player gap, well, if our player is 100 pixels wide, let's just make it easy, give them a 200 wide gap, and our let's see here, player gap, and then the gap between obstacles, we'll just do a 350 pixel gap. We can see how that looks. And then obstacle height, we'll just make it 75 pixels tall, and color, we'll do color dot black. That's our obstacle manager. So now that we've instantiated it, we just want to come down here to update. And I forget, do we even have, yes, we do have an update method. So we want to do obstacle manager dot update, and over here in the draw, we of course want to do obstacle manager dot draw, and draw with the canvas. So let's see if this works. I believe we are ready to run. So I'm going to pause the video and come back when I have it running. Alright, so we get an error right about here. So let's see. We have an error in populate obstacles. So let's click that. Let's see, here's the line. Okay. So here's the error. We basically, it starts out with no obstacles in it. So we have a problem because we're trying to reference, like this starts out at 0 and we're trying to reference it at index -1, so that's obviously an issue. So what we're going to do instead, since we're updating current X already, we're just going to say while current Y is less than 0. Let's just do that. And that should fix the error. So let's run it again. Hopefully we have no errors, and then if so, that'll wrap up the video, but we'll go ahead and see. Alrighty, here we are. Oh god, didn't mean to do that. Oh god. So here we go. We have obstacles generating and moving down our screen. Obviously, the purpose will be to move through it like this. And now let's let it play for a while. Oh god. So that was not... that did not work out well. So, we obviously have some stuff we need to fix. So let's go over here into Obstacle Manager, and it looked like as soon as stuff went off the screen, that's when we had problems. So, one thing we want to make sure we do is after we generate it, we want to just say obstacles dot remove, and we're going to say obstacles dot size -1. We want to remove the one that just went off screen, and let me make sure I am doing this correctly. We're going to say the highest index. We're going to see if it's top, it's below the screen, and we're going to generate a new one that's at the top, and then we're going to get the very first one. It's top. Oh, here's the issue. We want to subtract these. So go ahead and subtract them. Let's run it again, and we should be done. Alright, so we're about to the part where it messed up. Let's see. Okay, so it looks like it keeps going without any errors. So I think we are good. All these seem to be very close together, but it looks like everything's working. So I'm going to conclude this video at that. And next video will essentially make consequences if the player collides with it. And so yeah, stay tuned. I'll be making the next video soon.